Hello everyone, and welcome to another part of the Galaga SDL tutorial videos. And in this video we're going to add the final dive for the enemies, and this one will be the capturing dive for the bosses. So the class that we need to change first is our boss.h, and in here we will change mCapture the boolean to mCapture dive, just to make it a bit more descriptive and differentiate it from the other variables that we will add in here. Next up, we will need two more variables. The first one will be int mCurrentPath, and the second one will be another boolean called mCapturing. And that will be it for the variables that we need. Now for a function, we will need one new function called void handle CaptureBeam, and this will handle the logic for the CaptureBeam that we're going to create later on. And that will be it for all the changes that we need in boss.h. Now if we open boss.cpp, we will need to add a path for the capturing dive. And this dive is pretty short. So what we will do is copy this one. So the top part, the current path is going to be equal to 2 now, because increments by 1. We'll create a new path. And then underneath, we will add these 3 lines. So those 3, which adds the path, samples it, and then deletes the Bezier path that we created. And then in between here, we will add our curves. So the first curve for the capture path is pretty much identical to the curve for the escort path. So over here for path 0, we can just copy the first curve over here and paste it right there, because we just need a semicircle to make the boss turn around, and this is identical to the other one. And then we will add the second curve, and this one will be a little different. For the x value, for the first point, it will be at -90 and 0, and for the control point, it will be at -90 and 60. So not -60 this time. And then for the control point for the second point in the curve, it will be at 100, so positive 100, and for the y, it will be at 340. Then for the x, it will be at 100 as well for the point itself, and then for the points y, it will be at 400. And that will be it for our path for the capture dive. Now we need the second path, the mirrored one, to that, so we will copy and paste all this, change the 2 to 3, and then flip all the x's. So this one will be 90, 90, 90, 90, and this one will be -100, and this one will be -100. And that should be it for our paths for the capturing dive. Now to move on to the rest of our class, we need to initialize some of the variables that we created here. So capture dive, so capture dive is going to start off being false, which is fine. It doesn't really matter what we initialize it here to, because when we dive, we're setting it anyway. But it's good to just have it initialized just in case, so we can give it any value. We'll give it false. And then we will have our current path. So mCurrentPath is going to be equal to 1. And our mCapturing is going to be equal to false. Just initialize these 3 variables, and then we will be overwriting them later on anyway. Now to move on to our handle CaptureBeam, we will have void boss handle CaptureBeam, and this one is right above our dive state, our handle dive state. We don't need to do anything in here for now because we haven't created our CaptureBeam yet, so we can move on to our handle dive state. So in here we need mCapture. We actually don't need this anymore because this one is just setting the current path, and we just created a member variable for that here that we can set in our dive function. So we can just take out all this from here, and we'll just be left with our if statement. So instead of current path, we can change this to mCurrent path instead. And we'll do the same here. So we're just using the member variable instead of the variable that we were declaring up here. So these are the changes that we need in here for now. Now to move on to this part right here is when we finish the path. Because in a normal dive, in an escort dive, we follow the path all the way to the end of the screen and then teleport all the way to the top and then go back into formation. But for capture instead, we are following the path up to the point where we need to start capturing, and then we can start handling the capture logic. So this is the point where this change happens. So we will add 2 brackets in here for this if statement. And then in here we can say if it's a capture dive, else, and then in the else part we can add what we had before. So if it's not a capture dive, teleport. So if it's not a capture dive, just go to the world position. Now for this one right here, oh, I wonder why it's at 20. It should be at -20 because we want to spawn it off screen. So this should be at, we're teleporting it back to the top of the screen where the formation position is so that we can fly down. So that should be -20. Now for a capture dive, what we want to say is mCapturing is going to be equal to true, and our rotation is going to be 180 degrees. And this is because we want the bots to be pointing straight down when they start capturing. And that should be it for changes to this part. Now to move on to the else underneath, we can change this one to if not mCaptureDive or not mCapturing. So if we're not capture dive or not capturing, just follow the normal operation that we had before. Otherwise, so else, we can say handle CaptureBeam. So the whole idea here is if we are just following the path still, even if it's a capture dive, we want to follow the normal path. So go down and then teleport back up and go back into formation. But if it is not a capture dive, it's a normal dive, then we need to follow the normal operation. But if it's both, if it's a capture dive and we're capturing right now, we need to handle the capture beam. And this is gonna be it for this part. Now for our render, so we have here render dive state. First thing we need to take out the current path, so we can just take out all this, and we're left with the texture render and these this path right here, and this is just drawing our path. So instead of current path, we can use mCurrent path instead. So mCurrent path, mCurrent path, mCurrent path here and there. So just replace all the current paths with mCurrent path, and then down here in dive, we will need to do a few changes. So mCapture is now mCaptureDive. And then we will do the enemy dive, which is fine. And then if mCaptureDive, we will say that mCapturing is going to be equal to false. And then mCurrent path is going to be equal to 2 plus rand modulus 2. And this is just giving us a random of the two paths that we have, because the left side of the screen doesn't necessarily have to follow the left, the mirrored path or the left path. It can take the left path or the right path in the original game. So we're just making it random, whichever one that gets picked. And then else, we will have mCurrent path is going to be equal to mindex modulus 2, just so that the escort paths are still depending on which side of the screen the boss is on. And that will be it for all the changes that we need to do for the boss.h for now. So now we can go ahead and create our capture beam. So over here in Galaga, add new item, and this one will be called capture beam.h, and then if not defined, underscore capture beam underscore h, define underscore CaptureBeam underscore H, and then end F. Now, the CaptureBeam, the animated texture class handles almost everything that we want from the CaptureBeam, except for the part where it loads the CaptureBeam in pieces, because the whole beam is not rendered at once. I should probably show you what I have for the beam itself. So over here, if I open up the solution, the Explorer, debug assets, I should probably copy it over. There we go. And let's see, open. There we go. So this is what I have for the CaptureBeam. And this is just 3 frames of animations for the CaptureBeam. When the CaptureBeam is started, it needs to load up in sections. It can't just load up the whole beam at once. And this is not handled in the animated texture class. So we need to inherit from the animated class, the animated texture class in the CaptureBeam, and override some of that functionality. So we will include in here, so still in CaptureBeam.h, we will include animated texture.h, and we will be using namespace quick SDL. Now for the class itself, we will have class CaptureBeam, and that will inherit publicly from animated texture. Okay, so this is because we're going to be using a lot of the functionality that we already have in animated texture, but we just need to change a few things in that functionality. So let's open up animated texture.h for a second, because there are a few changes that we need to do in here. The first one will be changing this private for the variables to protected. And we will also need to add another protected section all the way at the end. So protected. And this one will be called, so virtual void run animation. And that will be it. Oh, right. And one more thing is reset animation. We need this one to be virtual as well. So virtual void reset animation, and we have this one. So in animated texture.cpp now, we can go down and implement our run animation function. So all the way here at, maybe all the way at the top, we will do void animated texture run animation. And for this one, what we will do is take in everything inside the M animation done, if not M animation done, and we will paste it in run animation. And then over here, inside the update, we will just say run animation. So if the animation is not done, just run the animation. And these are all the changes that we need to make for our animated texture class. Now we have everything ready for our CaptureBeam class. So for the CaptureBeam, in the .h, we will need 2 variables. The first one will be, so private, the first one will be a float, m total capture time, and a float m capture timer. So this is how long it takes for the beam to come out, stay on screen, and then go back. And then this one will be our capture timer to keep track of the time for us. Now private. For the functions, we will have void run animation. So we're overriding that from the parent class. And finally, for public, we will have the constructor, which will be CaptureBeam, the destructor, and void reset animation. So that's overriding it from the animated texture class. And virtual void render, because the animated texture, the CaptureBeam renders differently than the animated texture. We need to clip the beam as it's being loaded in, and then clip it backwards when the beam is when the CaptureBeam is ending. So that will be it for our CaptureBeam.h. Next up, our CaptureBeam.cpp. So let's create that. So in source files, add new item, and this one will be CaptureBeam. Include CaptureBeam.h, and for this one we will do CaptureBeam. For the constructor, we need to initialize all the variables for our animated texture base class. So we will have animated texture, and let's see here. The texture name that we have is called CaptureBeam.png. So that will be here, CaptureBeam.png. Let me open it once more. For our CaptureBeam, I have the starting X and Y is 0 and 0, so that can be 0 and 0. The width for each one of these frames is 184 for me. It might be different for you. So for mine, it's 184 for each animation frame, and the height is 320. Now the frame count is 3. The animation speed, we will have it as 0.5. So this is how fast to run through these animations. So half a second to run through all of these. And then the animation direction is horizontal. And that will be it for our base class. Now we just need to initialize the two variables that we have. So these two variables are total capture time. So total capture time is going to be equal to 6.0f. And we will do a reset animation inside the constructor when we start off. So that will be it for our CaptureBeam constructor. Next up, our destructor. It doesn't have anything in it for now, so we can just leave it empty. And then our reset animation. So void CaptureBeam reset animation. For this one, we will call our animated textures reset animation. And then we will set our capture timer to 0.0f. And our clipRectangle.h equal to 0. And this is because the clip rectangle is what we're going to use to cut the beam when it's loading in and going out. So that will be it for our reset animation. Next up is our run animation function, and this is the big function in this class. So void CaptureBeam run animation. We will do capture timer plus equals timer delta time, and then we will do if the capture timer is more than or equal to the total capture time, then the capture animation is done. So we'll say animation done is true. So that will be it for this part. And then else, now we need to handle the logic for actually running the animation. So loading the animation in, keeping it on screen and running the animation for a while, and then taking the beam back out. So in here we'll say animation timer plus equals the timer delta time. If the animation timer is more than or equal to the animation speed, then we will do animation timer minus equals animation speed, just to keep looping the animation because we need to keep it looping until the animation is done. Now to move on to our clip rectangle, we'll say cliprect.x is going to be equal to int of animation timer divided by time per frame, and all this will be multiplied by the width of each frame. And that will be it for this part. Now for loading the animation in and taking it back out, we can say if the clip timer, or the capture timer, is less than 2.0. So for the first 2 seconds of the animation, we want to load the beam in. So we'll say float temp is going to be equal to an int of mCapture timer multiplied by 3.5f. And then mClipRect.h is going to be equal to int of temp divided by 7.0f, and this one will be multiplied by mHeight. And I'll explain in a second why the 3.5 and the 7.0. Now this will be it for loading the CaptureBeam in. Now for taking it out, we can say else if the capture timer is more than our total time minus 2.0f. So in the last 2 seconds of the animation, we can say float temp is going to be equal to, so it's the same idea as this one, m total capture time minus m capture timer, and that's going to give us a value between 0 and 2, just like this one, multiplied by 3.5f, and then mClipRect.h is going to be equal to int of temp divided by 7.0f multiplied by a height, mHeight. Now, if it's not this or that, we need to have the ClipRect.h to be equal to the height. So we can say else mClipRect.h is equal to mHeight. And that will be it for this function. That covers pretty much everything, loading it in, taking it out, and whatever is in between. Finally, we can now override our render function to render this new state that we have. So we can have void CaptureBeam render, and just to save some time, we can go to, and to save us any syntax errors or typos that we might make, we can go to our texture.cpp all the way down. In our render, we can just copy everything that we have in the texture render and then paste it right in here. The only change that we need to make is right here for the renderdirect.h. We need to change this one to be mClipRect.h. And that will be it for these changes. And yeah, that should be pretty much everything. Now we can go to our level. So in level.cpp. And in here we can add the functionality or the logic to make the boss dive using a capture dive instead of an escort dive. So in here, all the way down, where are we doing the diving? This is the spawning, handle formation, handle enemy diving. There we go. So over here we are doing diving for the wasp. So let's copy what we have here for the wasp and then take it all the way down here and paste it right there. So over here we can do, let's say W, so scan code W. We can say that if the enemy is a boss and the boss is currently in formation, we want to dive, but this time we want to dive using our dive 1. And that should pretty much be it. So we can now try to run the game and see how it goes. So that was in handle enemy diving. We just added another if, but this one is the key W, and then if it's a boss and it's information, make it dive using dive with parameter 1 instead of 0. Okay, so let's spawn all our enemies. There we go. And once their information, we can press W, and there we go. But the capturing is not working. That's because we haven't created an instance of the CaptureBeam. So in boss.cp.h, we can now include CaptureBeam.h, and down here we can say CaptureBeam pointer mCaptureBeam. So just create a variable from our CaptureBeam class, and in boss.cpp, in our constructor, we can say mCaptureBeam is going to be equal to a new CaptureBeam. Now we need to position the CaptureBeam in the right place. So the first thing that we need to do is to make the CaptureBeam a child of the boss. So mCaptureBeam parent is going to be this. And then for the position, it's going to be a little off. So mCaptureBeam position, just remember that this is local to the boss. So it's relative to the boss. So our position will be a vector2 of, on the x, we want it to be centered on the x, so it can be 0.0f. And on the y, we need to make it negative 190.0f. So negative 190. And the reason why we're putting it above the boss is because when the boss is capturing, it's actually rotated 90 degrees. And since it's rotated 90 degrees, we want the CaptureBeam itself to be upwards so that when it's rotated, it flips and becomes underneath the boss. And then we can say mCaptureBeam rotation is going to be equal to 180.0f. And the reason for that is because right now it's upwards, but it's flipped upside down. So we need to flip it right back up so that when it's pointing down, it's in the right orientation. And that should be it for the constructor. Now for the destructor, we need to delete it. So delete mCaptureBeam. And mCaptureBeam is going to be equal to null. And in handle CaptureBeam. Now for handle in the CaptureBeam, we need to run the update for the CaptureBeam. So mCaptureBeam update. And then if not mCaptureBeam is animating. So if the animation is done, we need to finish up the final part of the dive, which is to go off screen and then teleport all the way back up. So in here we will say if, or translate. So if it's no longer animating, we want to go off screen. So we can say translate by a vec2 underscore up multiplied by mSpeed multiplied by mTimer delta time. So start going downwards depending on your speed until you're off screen. So if the position dot y is more than or equal to, let's say 910.0f, so that's off screen, our position, we need to put the boss all the way back to the top of the screen because we just went at the bottom of the screen, we want to go back up. So our position is going to be equal to a vector2 of the world formation position dot x and negative 20.0f. Now our mCapturing is going to be equal to false, and that will be it for this function. For our render, so when we're doing the render dive state, we need to render our CaptureBeam. So down here underneath the for loop, we can say if mCapturing and mCaptureBeam is animating. So as long as it's animating and we're capturing right now, mCaptureBeam render. And that will be it for the CaptureBeam. So let's run that and see what it looks like. Hopefully it works. So let's spawn all our enemies. Okay. Wow. Okay. So that is kind of off a little bit. So the first thing that we need to do is to actually fix up the going backwards. So for that, when we're translating in here, so in handle capture beam, in the translation, we need to translate using the world axis. Now, secondly, for some reason, it's diving in before the enemy is in formation, I think. Let's try that again. Let's load them all back in. Yep, so it's diving before that goes back into place, and then the beam is not going up in sections. So we need to fix these two things. So in our level.cpp, let's see what's going on in here. Oh, I put it outside the formation locked. That's why. So it needs to be inside this bracket right here because we're waiting for the formation to lock. So now it shouldn't dive after the boss. It shouldn't dive before the animation of the formation locks. So let's spawn all the enemies again. There we go. Now it doesn't dive before it locks, and then once it locks, it goes up in sections. So it loads up in sections, but then when it's disappearing, it's going up in a smooth transition. So we need to change that to actually disappear. In chunks. So else if the capture timer is more than the total capture time minus 2.0. Oh, I didn't cast it into an int in here. That's why. This needs to be casted into an int so that it cuts any extra pieces that are there, or any fractions that are there. So when that works, I will try to explain why the 3.5 and 7. So, okay, there we go. And as you can see, it's a random path every time. Okay, so that seems to work now. So now for the 3.5 and 7 is because the sections are loaded in 7 sections. If it's 4, this would have been 2, and this would have been 4, and so on. So that's the whole idea behind that. So when I was editing this video, I noticed there was a bug that I did not notice when I was making the video before, is that when one of the bosses dives and they do the capture animation, they don't do it again if I try to make the same boss dive once more. So let me show you what I mean. So now we have all our enemies in, and this boss is going to be the first one to dive. So if I make this one dive, it's going to go through the full animation, and then it's going to fly off screen. But then if I try to make it dive again, as you can see, it just flies right through. And the reason behind this is because we are not resetting the capture beam animation once we are done, or once we want it to start running. So in dive, in the dive function in the boss class, what we need to do is right underneath current path, we need to say m capture beam reset animation, and that's pretty much all we need to do. So now we can do we can run the game once more, and that should theoretically fix that problem. So let's spawn all our enemies. And there we go. So the boss runs through the full animation here. And then we'll wait once he's back information. We run it again, and there we go. So now we'll place the animation one more time. Okay, and that should be it for this video. I really hope it helped. If you have any questions, suggestions, or feedback, please leave them below. Otherwise, thank you very much for watching, and I will see you in the next video.